Now we will look at adding and subtracting complex numbers. The nice thing about adding and subtracting complex numbers is that it's very, very similar to the process of combining like terms. So these problems should feel very familiar to you if you're used to combining like terms. So let's take a look at part A. Like I said, all we're going to do in part A is combine like terms. So we can combine our constants, which are the positive 5 and the positive 7, and then we can combine the imaginary parts, which are the negative 11i plus the 10i. And we don't really even have to worry about the parentheses in this problem because the parentheses are separated by a plus sign, so we don't have to worry about subtracting the set of parentheses or distributing a negative 1. So all I'm going to do is rewrite my problem because sometimes that helps, and I'm going to put the like terms next to each other. So 5 plus 7 minus 11i plus 10i, and then I can see how I can combine the like terms. So this equals 5 plus 7 minus 11i plus 10i. So 5 plus 7 I add together for 12. And then when I add negative 11i plus 10i, really all I'm doing is adding their coefficients, the coefficients of the I term, and then the new coefficient becomes, or the sum of negative 11 plus 10 becomes the new coefficient on I. So negative 11 plus 10 is negative 1. So my final answer here is 12 minus I. You could put plus negative 1i, but it's more simplified to just write 12 minus I. Let's take a look at part B. Since we are subtracting the second complex number, we do need to distribute negative 1. So our first complex number stays as negative 5 plus 7i, but then I minus 11 and add 6i. Now I'm going to combine like terms. So I can combine the real number constants, negative 5 and negative 11, but then I'm going to have to combine the imaginary parts, which are the 7i plus the 6i. Negative 5 minus 11 gives me negative 16, and 7i plus 6i gives me 13i. In part C, I will also have to distribute a negative 1 for the last set of parentheses. So I have the constant 5 plus 3 plus 3i, and then when I distribute negative 1, it becomes minus 4 and minus 2i. So again, I'm going to add my constant terms together, so 5 plus 3 and minus 4, and then I will combine the imaginary terms, which are the positive 3i minus 2i. So when I add 5 plus 3 and subtract 4, that becomes 4 because it's 8 minus 4. And then when I add the imaginary terms together, positive 3 minus 2 becomes the new coefficient on the I. So I get 4 plus 1i, or just 4 plus I. And in part D, we have another subtraction problem, so I will have to distribute the negative sign. So I get 2 plus 6i minus 12 plus 4i, because the negative times a negative is a positive. So I will start by adding my constants. 2 plus negative 12 gives me negative 10. And then when I add the imaginary parts, I will also get 10i. So I'm going to start with negative 10, and then I'm going to add 10i, and that's my final answer.